Hi, Mark Hall with Alabama Cooperative Extension System. In this segment of the Short Rotation Woody Crop Series, we'll look at harvesting trees and how we can regrow the trees from the stumps.
My name's Tom Gallagher. I'm an Associate Professor of Forest Operations for the School of Forestry and Wildlife Sciences of Auburn University. What we have going on here is we're harvesting our poplar plantation, trying to come up with more efficient ways to coppice it, but this specific study is more about how it's going to coppice back out. It's an expensive crop to plant, and therefore one planting has to yield 4 to 6 harvests, and so we have to make sure that we can harvest it correctly to make sure that we get those additional harvests. So IBSS is the Integrated Biomass Supply Systems. It's government-funded, USDA government-funded project in association with University of Tennessee and North Carolina State University. And then we also have some private partners like Arborgen and a few other individuals. And that group is looking at trying to develop more efficient ways to bring a cellulosic ethanol to market. And while a big portion of that is what goes on in the lab, the final conversion process, Auburn University and IBIS is sort of looking at the whole process from what we say stump to pump. So how can we be more efficient in the woods, and then more efficient in transporting it, and more efficient in processing it before it finally gets to the lab, where they're going to hopefully get more efficient at making the final conversion from a woody material to a cellulosic ethanol for use in our vehicles.
My name is Christian Broadbeck. I'm a research engineer with Auburn University Biosystems Engineering. As our need for fuel increases, if we're going to use biomass to convert that into a fuel, the more biomass we have, the more fuel we can make. So typical pine plantations nowadays have a rotation of 15 to 20 years. That means you're only going to be able to remove material every 15 or 20 years. So if we can find a way to grow quick trunk plantations, whether it be pines on a 10-year rotation or something like this, a hybrid poplar or a eucalyptus on a 3 to 4 year rotation, that means now we're getting more biomass in a shorter time period, so we can have more material to convert into our fuels.
We're trying to experiment with crops that will efficiently grow in this area, economically produce something positive for the landowner, in addition to bringing a fuel to the market that the market can make money off of too. It's got to work for everybody. When you're harvesting large diameter trees, it's easy to be efficient with that because they're large, they weigh a lot. You have specifically developed machines to do that. Well, we're on the small end of things now. We're dealing with small trees, so we're trying to do that, again, more efficiently, smaller machines. We're looking at a shear head that sort of pinches the tree off, because the saw head's expensive. It's only with big machines, and we're trying to do it with smaller machines. And then we have a small skidder that brings them out, and then when we get to the landing, we chip it up. So then we'll take that, and that's what's going to be fed directly into the process for making gasification or pyrolysis to make a liquid fuel. Coppicing is the ability of the tree to regenerate after it's been cut off. So most plants, trees, you cut them off at the stump, it's gone, it's done. Like pines are like that. But there's specific hardwoods that when you cut them off, they'll sprout right back out of the roots. And as a matter of fact, usually the second, third, and even the fourth generation actually will outproduce the first one, because you'll get multi-stems, the root system's already in the ground, already bringing the nutrients in. So the second, third, fourth generation of trees, rotations, and then you start everything gets tired. The roots get tired, the tree gets tired, and you start kind of falling off on your production, and that's when you have to wipe it out and start over again. But if you got a 3 or 4 year rotation and you get 5 to 7 rotations out of it, you're looking at 20, 25 years before you have to go in and redo your stand.
We'll come back in the next few months, and we'll actually go to each stump and count how many stumps coppiced back. We already counted what's out here before harvest, and that will give us a good idea of before and after, how well are we coppicing.
Weed control can be a problem, and that's one of the things that we're learning with this harvest here. We're, like I say, this is all still a learning process, and that first year is critical. So you have to really keep the weeds down that first year. We sprayed yesterday to get the weeds down so that hopefully the trees will then come out of the ground. The trees will come out of the ground fairly quickly. You know, within a month or so, you'll start seeing new sprouts come out of the ground, and within a couple, 3 months, you'll have sometimes 4 and 5 foot stems. And then the grasses aren't as big a problem. But boy, that first couple, 3 months, the grasses can be a problem. So that's why you got to treat it usually over the course of the first year. Then once the trees are up, you're good. You know, the estimate is we're growing somewhere between 8 and 10 tons per year green material. And you expect that to go up by probably 50% for the second and third cutting before, again, by the third, fourth cutting, it starts tailing back down. And then it's sort of an economic decision when you say, okay, start over again. So there's a good growth, good increase in the second cutting and third cutting, and then it starts falling down.
Doing this project with IBIS, we see that there probably is potential for short rotation crops. We've seen it done in other countries, and I think we can definitely see that there's a potential to use short rotation crops for fuel purposes. So, you know, we're not quite there to figuring the economics out. Definitely the system, we know how to do it, we know how to grow, we know how to harvest, we know how to convert it, whether it be through thermochemical process or some sort of biochemical process, and we know how to make the fuel. So we can do the whole stump to pump process. That we have figured out. What the challenge is and what we're really looking at during this IBIS project is how to bring that cost down to something that we can compete on the market with, you know, the price per gallon of, let's say, diesel fuel. So that's the one challenge. So I guess what the main thing I'd like to add is I do see a future in short rotation crops, and we can do it. We just need to figure out how to do it more economically.
We're still learning. It's still a learning process, and it's a learning for everybody. I mean, I think we have to learn, we have to do a better job figuring out how to establish it at a lower cost. We got to learn how to manage it and grow it at a lower cost. We have to learn how to harvest it and transport it at a lower cost. And then the biggest thing is we have to get the market or the you know, to change it, to gasify it, or do whatever they're going to do to make it into a applicable fuel that we can drop into our cars and trucks and wherever we need to be. So we're still a little ways off from making it happen. Can we make it happen? Absolutely. We can do it. We can grow trees, we can cut trees, we can even make a cellulose ethanol out of running your cars. We know how to do it. The problem is we can't do it at an economically feasible price, and that's what all this is working on, getting it down to an economically feasible application of this process.
Tom and Christian harvested these trees only 4 weeks ago. As you can see, they really have grown back out, as have the weeds. If I can help you with your short rotation woody crops, please let me know at hallmah@auburn.edu. That's hallmah@auburn.edu. Thanks for watching.